I have a bottle of water here, and there's two holes which are drilled in the side, one here and one here, one at the top, one at the bottom. If I take off these pieces of tape, water will come squirting out of the side of the bottle. Question, from which hole will the water emerge at a higher speed, at the top or at the bottom? We'll give you some choices. Now you know what's going to happen. If I take the tape off this top hole, the water will come out, but it comes out pretty slow. If I take off the tape on the bottom hole, the water comes out much more quickly, comes out much more quickly. And the reason is this, there's a higher pressure down here. As I go deeper and deeper and deeper in the fluid, so if I go from the top down here to the bottom, the pressure increases. There's a higher pressure at the bottom, and since there's a higher pressure, it's going to push the liquid out at a higher speed. And so I'm going to have higher speed liquid coming out the bottom, and it's because of the difference in pressure. And you know this. As you go deeper and deeper in a fluid, the pressure goes higher and higher and higher. And this is one of the first relationships that you're introduced to in Chapter 13, is this variation of pressure as a function of depth in a fluid. And here's a very, very practical application of this. If you're having your blood pressure taken, they put the cuff on your arm right here. And there's a very practical reason for putting the cuff right here. It's at the same level as your heart. And the blood pressure measurement that is clinically meaningful is the blood pressure at your heart. And so what they do is just measure the blood pressure at the same level. Because the equation for the variation of pressure as a function of depth in a fluid applies to your circulatory system just as surely as it applies to a bottle of water. So they measure the blood pressure right here. And I can show this by using this wrist cuff. And this wrist cuff will measure my blood pressure at my wrist. And I'm going to do a couple of measurements, and I'm going to start by doing this. I'm going to measure my blood pressure at the level of my heart. I'm going to measure my blood pressure at the level of my heart. And what happens is this. I turn on the device, and it pumps up this cuff. And it pumps up the cuff until the pressure in the cuff is high enough to stop my blood from flowing. And so that's a measurement of my blood pressure. How hard do you have to squeeze in order to keep the blood from flowing? And let's focus on just the top number. We'll focus on just the top number here. My blood pressure is 104/73. So pay attention to that top number. Pay attention to that top number. When this cuff has a pressure of 104 millimeters of mercury, it's high enough that it's higher than my blood pressure, and so blood does no longer flow through my artery. That's how you make that measurement. So 104 is the top number. Now let's suppose I do this. I raise my hand up like this. So now my hand is higher than the level of my heart. If I repeat the measurement and take my blood pressure at this greater height, will I measure a higher pressure or a lower pressure? We'll give you some choices. And now, let's just take a measurement and see. Before, it was 104. Now, with my heart right here and my hand up here where the measurement is being taken, let's see what we get. Net result, top number, 62. 62/46. And it's not that my blood pressure has suddenly dropped to a level where I would probably be passing out. It's just up here at a height above my heart, I'm higher up in the column of the fluids, that's my circulatory system, and so I measure a lower pressure. And so to get a clinically reasonable measurement of blood pressure, where you measure, where the cuff goes, has to be at the same level as your heart. Now, Chapter 13 is about fluids, and for physicists, a fluid is anything that flows. And so fluids are water, but fluids are also air and other gases. So you can move at different elevations in the atmosphere, and as you do that, you'll experience a difference in pressure. And for that reason, you're going to have different pressures at different elevations. And to explore that, we're going to go to the elevator. So here we are, we're in the elevator, and so we can move up and down. And so we can move to different elevations in the atmosphere. So we're going to come to a stop and take a reading of the pressure. Okay, so the pressure, 853.8 hectopascals, or 85.38 kilopascals. So 85.38 kilopascals. Now, the elevator is going to move again. And as I look at the pressure reading, it's increasing. It's increasing. And now the pressure is going up. Question, are we going up or are we going down? We'll give you some choices. And in fact, we were going down. Here we are in the basement, and we're at the higher pressure because we're lower down in the atmosphere. We're lower down in that column of fluids, and so we're at a higher pressure. And if we go back up to the top floor, the pressure will drop again. And it drops measurably. It drops measurably. Now this device is a GPS unit. And the way that it measures altitude is not by looking at satellites. It measures it by looking at pressure. That variation of pressure as a function of height is responsible for the next big topic, which we'll look at in Chapter 13, which is sinking and floating, the whole idea of buoyancy. We'll pick that up in the next segment.